All right, we're trying to solve this equation right here. I'm going to write my steps and my optional work on the right-hand side here. Step 1, I always need to get a quadratic equation equal to 0. I'm going to add 10 and subtract 5x from both sides. Write them so that your like terms match up, so that you can see that 45x minus 5x is 40x. You get plus 100 equals 0. And I'm going to bring down the 4x squared and separate it with an addition sign. I'm always going to see if it factors, and now we're going to start to see multiple levels of factoring. You always start with, is there a greatest common factor? Out of 4, 40, and 100, I'm wondering if they all share a factor in common. And if I think about the number with the least amount of factors first, it helps me narrow down what my choices are. 4 only has factors of 1, 4, and 2. And so if you think about the largest of them, the number 4 goes into 40 and 100. 40 is 4 times 10. 100 is 4 times 25. So they all have a factor of 4 in common, and they can't have anything larger than that. So let's rewrite our 4x squared plus 40x plus 100 in our blown up factored form for our side work. So I'm going to rewrite 4x squared as 1 times 4 times x times x. I'm going to rewrite 40x as 4 times 10 times x. And I'm going to rewrite the constant 100 as 4 times 25. Then we're going to pull that common factor out and rewrite it in the factored form. So take your greatest common factor, pull it out, and then think about what's left. I have a 1 times x times x. That's 1x squared. I don't need to write the 1. In my next term, I have a 10 times x. So I'm going to write plus 10x. And in my final term, I have just 25 if I take the 4 out. So I'm just going to transfer that to my required work side. Put equals 0. Now my next layer of factoring, I'm going to say that this is a whole separate step, is can we factor that trinomial that's inside the parentheses? So can I find factors of 25 that multiply to 25 and add up to 10? So out of x squared plus 10x plus 25, I'm thinking the factors of 25 are 1 and 25 or 5 and 5. And I will choose 5 and 5 because those are going to add up to a positive 10. So x plus 5, x plus 5. Now I've factored the stuff in parentheses farther, so I'm going to write that underneath in my required work. So just this part is going to factor into x plus 5 times x plus 5. And the 4 is just going to come down. Now my last step, I'll just say step 4, is let's actually solve this for x. I'm going to use my zero product property. if each factor multiplies to a product of 0, then each of those factors could possibly be equal to 0. And I realize that the x plus 5s are matching. You don't need to write them twice if they're matching, but in general, you want to set each factor equal to 0 and solve. Now, if I see 4 equals 0, that's really strange because 4 never equals 0. So I would just write 4 is not equal to 0 and realize that this factor is not going to generate a solution for x. And then these are matching, so I really only have to solve x plus 5 equals 0 one time. I don't know why I just rewrote it. But I'm just going to subtract 5 from both sides and get x equals negative 5. And if the third factor was different, I'd have to solve that one as well. But I would still get x equals negative 5. It's a double root. You don't need to solve it twice. So this equation just resulted in one solution of x equals negative 5.